Okay, ladies and gentlemen, lesson for today is 7.4, factoring quadratics in the form ax squared plus bx plus c. A little bit different today in the fact that now there's going to be a leading coefficient other than 1 that we're going to have to deal with, and the way that we do that is by using something known as the British method. The British method starts out by taking the outside two terms of your quadratic trinomial and multiplying them together. That number then is split into two terms that when added together give you your middle term. So in this case we have 2x squared times 12, which gives us 24x squared. And the factors of 24x squared that when added together give you 11x are 8x and 3x. So the second part of that then is to break 24x squared down into those two factors and to rewrite our original quadratic trinomial as a four-term polynomial. After this, we factor the first two terms and the second two terms individually by factoring out their greatest common factor. This is very similar to the first thing we did in our video for 7.3 when we showed how multiplying in a monomial and being able to pull it back out using the greatest common factor. So in the first group here, you see that we have 2x squared plus 8x. The greatest common factor there is 2x. So that's been factored out front and leaves us with 2x times the quantity x plus 4. Our second group, 3x plus 12, the greatest common factor for that group is 3. So we factor out the 3, leave it out front, and that leaves us with the quantity 3 times x plus 4. Now, since the x plus 4 is common to both of those groups, that becomes the first of our two factors of that original quadratic trinomial. Then the two terms that are outside the x plus 4 are combined together to create the second binomial of our quadratic. So let's take a look at this again, but let's do it this time by looking at an example together. So the example that we have, ladies and gentlemen, is 3x squared minus 19x plus 30. So the first thing that we are going to do here is we are going to multiply our two terms, our outside two terms together. In this case, 3x squared times 30 is 90x squared. So now we're asking ourselves the question, what factors of 90x squared when added together give us negative 19x? Here, a quick throwback to lesson 7.3 as well. Remember when the middle term was negative and the constant we said was positive? Then we'd have to take a look at it from the standpoint of, is it going to be the same signs or the different signs? In this case, since it's negative 19 and this we have as a positive 90x squared, that means both of the terms have to be negative. So in this case, those two terms in any order would be negative 10x and negative 9x. Please remember that the sign goes with the terms. We then bring down the outside parts of our original trinomial, and that would leave us with 3x squared minus 10x minus 9x plus 30. So now, ladies and gentlemen, we go through a process known as grouping. We group the first two terms together, and we also group the second two terms together. In the first group, we have 3x squared minus 10x. The greatest common factor there is x. So if we factor that out, that leaves us with x times 3x minus 10. The second group brings in the idea of having a leading term that's negative. If the leading term or the leading coefficient of your second group is negative, then what you have to factor out must also be negative. So what's the greatest common factor of negative 9x and 30? The answer is negative 3. So if we factor out a negative 3, that leaves us with 3x minus 10. So once again, as we saw on our previous screen, since the binomials in the parentheses are identical, that one becomes our first binomial. 3x minus 10. And then the terms that we see in front of those binomials become their own binomial, which would be x minus 3. So now let's take a look at a couple of examples, a couple more examples that we have dealing with some different sign choices as well. So in this case, the last one we had was a negative middle term and a positive product on the outside. In this case, we are going to have a negative product. Let's see if that changes anything up. So here we have 6x squared times negative 4, which would leave us with negative 24x squared. Since that product, negative 24x squared, is negative and the middle term is negative, that means we're going to have one factor of each, and the larger value will be negative. So the two factors of negative 24x squared that when added together give you negative 5x are negative 8x and positive 3x. We then bring down the outside two terms, which would leave us with 6x squared and minus 4. And once again, like we did before, now we group. We group the first two terms together, and we group the second two terms together. The output that we want to see here is after we are done with our greatest common factor is that we are left with that same binomial factor inside the parentheses. Greatest common factor in the first group is 2x, which leaves us with 2x times 3x minus 4. The second one is unique in the fact that if you look at it, you might say it doesn't have a greatest common factor, but in fact, no matter what, every set of terms has at least the greatest common factor of 1. So that's what we're going to factor out in this case. In doing that, we have once again successfully factored down so that the binomial inside the parentheses is the same. So once again, that becomes our first binomial factor. And then the terms that are outside of those factors become our second binomial factor as well. So as we go through these, ladies and gentlemen, you're going to notice that the consistency of the process will fit any type of quadratic we run across. The last quadratic that I have for you is one that brings into play a unique situation in factoring using the British method. So the first step that we are going to take is the exact same step we took before. We're going to take the first term and the third term and multiply them together, which would give us 50x squared. So now we're looking for the factors of 50x squared that when added together give us negative 19x. So in this case, we're looking for two negative factors that when multiplied together give us a positive 50x squared, and when added together give us a negative 19x. The problem with this situation is no matter what two negative factors of 50 you put together, so negative 1x and negative 50x doesn't work. Negative 2x and negative 25x doesn't work. And negative 5x and negative 10x does not work. So in this case, ladies and gentlemen, at this point, since there are no factors for us to use from negative 50 or from 50x squared to add up to negative 19x, we consider this type of a trinomial to be unfactorable. And since it's unfactorable, we can't go any further. In this case, we would be done. So remember that if you run across something that's unfactorable, it doesn't necessarily mean that down the line we can't solve it. It simply means that we cannot use it or to solve it using factoring. All right, ladies and gentlemen, that's our lesson here for today. Again, if you do have questions, please make sure you save them and ask them in class. Other than that, Lord's blessings on everything. I hope you're staying healthy and safe, and I look forward to seeing you in class very soon. Have a good day.